A serial dilution is the stepwise dilution of a substance in solution. A tenfold serial dilution could be 1 molar, 0.1 molar, 0.01 molar, or 0.001 molar. It is obvious that we are trying to make solutions of much lower molar concentration from a stock solution that has a much greater molarity. The goal of the first lab is to observe the effects of varying sodium concentrations on fertilization. Solution 1 and 2 will both have a sodium concentration of 0.484. Solution 1 is natural seawater, while solution 2 is artificial seawater. And then solutions 3, 4, and 5 will have a diluted sodium concentration, while 6 will have a sodium-free environment. Let's go ahead and take a look at an example of a serial dilution. Mark has a 4 molar solution of Mike's Hard Lemonade and wants to perform a serial dilution to have 3 solutions which have a diluted alcohol concentration. The first solution is 4, the second is 0.4, and the third is 0.04. To start, Mark has an M1 of 4M. He desires a concentration M2 of 0.4. He removes 1 milliliter, or V1, from his 4 molar stock solution. This calculation tells us that our final volume, V2, is 10 milliliters. Thus, we will have to add 9 milliliters of water to the 1 milliliter of solution 2. Mark has a 4 molar concentrated solution of Mike's Hard Lemonade. He wants to dilute this tenfold to make a 0.4 molar concentration of Mike's Hard Lemonade. To perform a serial dilution, Mark is pipetting out 1 milliliter of Mike's Hard Lemonade. Mark then adds 9 milliliters of water to solution 2, which contains the 1 milliliter of 4 molar concentrated solution. This is now a diluted solution of 0.4. To make a third tenfold serial dilution of 0.04, Mark takes a new clean pipette and takes out 1 milliliter of the 0.4 molar test tube 2 solution and adds this to test tube 3. Once again, Mark will then add 9 milliliters of water to test tube 3 for a final concentration of 0.04. To reiterate, Mark now has 3 solutions: a stock solution of 4 molar, a tenfold diluted to 0.4, and another tenfold diluted to 0.04. In this dish will be a yellow solution. This yellow solution are eggs. Use a glass pipette and suck up a concentrated drop of egg. Place 3 to 4 dots evenly spaced out. Next, take the corresponding solution that will be numbered either 1 through 6 and pour into the dish with the eggs. Next, to remove the sperm, take a toothpick, a clean toothpick each time, and remove the sperm and then carefully swirl in the Petri dish. Repeat this procedure for solutions 1 through 6. After the egg and sperm have fertilized, pour the solution into the test tube. Cap the test tube and hand centrifuge. Hand centrifuging. Remove, and you will observe a yellow pellet at the bottom with a water solution on top. Dump the water solution and resuspend in natural seawater. After resuspending, pour back into the Petri dish. Then, take a glass pipette and suck up the solution and place a dot on the microscope slide. Then take the microscope slide to the microscope to observe fertilized eggs. Fertilized eggs contain the fertilization envelope and appear as a yellow halo. After counting plates 1 through 6 for fertilized eggs, place your plates in the cold room for first cleavage. Wait approximately 30 to 90 minutes to observe first cleavage. During this wait period time, we will be talking about statistics and the problem set 2, which will consist of a protocol and materials request list.